In this lesson, we're going to be looking at the circles, conic sections, circles. A circle is the set of all points in the plane that are equidistant from a given point in the plane called the center. In this figure, the radius is the distance from the center to every point on the circle. And each point on the circle has a corresponding x and y coordinate. Standard form of a circle is x minus h, that quantity squared, plus y minus k, that quantity squared, equals r squared, where h comma k is the center and r is the radius. The general form of a circle is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are constants. Example 1, we need to graph this circle. So we can see that the center of the circle is going to be the origin, 0, 0. And 4 represents the radius squared, so that means the radius is the square root of 4, or 2. And this is what the graph of that circle would look like. A circle that has the center at the origin and a radius of 2 units. For this example, we want to determine what the center and the radius is. So the x-coordinate of the center is 0. Y-coordinate of the center is the opposite sign of what's inside the parentheses next to the y, so it would be -3. So the center is 0, -3. And 1 represents the radius squared, so the square root of 1 is just 1. In this example, we want to again find the radius and the center of the circle. So first thing we want to do is move everything over to one side of the equation. You can just leave the constant on the other side. Put the terms on the side that's going to make the x squared and the y squared terms, make them both positive. And then now we're going to need to complete the square for the x expressions. So we take half of that linear term, half of -8 is -4, and then -4 squared is going to complete the square. So 16 will complete that square. And because we're adding 16 to the left side of the equation, we need to also add it to the right side of the equation. And then now for the x's, we have that perfect square. If we factor x squared minus 8x plus 16, we get x minus 4, that quantity squared. And we still have the plus y squared, and then -12 plus 16 is 4. And then now we have our equation written for the circle. It's written in standard form. So we can see the x-coordinate of the center is +4, y-coordinate of the center is 0, and 4, it represents the radius squared. So if we take the square root of 4, we get a radius of 2. Next example, we want to write this in general form. All right, so the first thing that we want to do is go ahead and expand each one of those binomial squares. When we do that, we get x squared minus 6x plus 9 plus y squared minus 16y plus 64, and then subtract 49 from both sides so that the whole equation is set equal to 0. Combine any like terms so that we've got constants that we can add. So we should have x squared plus y squared, and then minus 6x minus 16y, and then 9 plus 64 minus 49 is 24. And that is our equation written in general form. We want to write in standard form the equation of the circle that has a center at -6, 11, and a point on the circle is -1, 15. So we're going to use the center and a point on the circle and the distance formula to find the distance between the center and the point on the circle. That will give us the radius. So subtract the x coordinates, square that amount. Subtract the y coordinates, square that. We get 25 plus 16, which is 41. So the radius is the square root of 41. So now we can write our equation. X minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. So x minus -6 is just x plus 6. And then the square root of 41 squared is just 41. That is the equation of our circle written in standard form. And then lastly, we want to write in standard form the equation of the circle that has these 3 points on the circle. So we're going to use the general form to write the equation. So we're going to use the first, plug the first coordinate, plug in 5 for the x's in the general form of a circle, and then plug in -9 for the y. Do the same thing for the second coordinate, plug in 7 for the x, plug in -15 for the y, and then the same for the third coordinate, plug in 7 for the x, plug in -9 for the y, and again we were plugging those coordinates, the x's and the y's, into the general form of the circular equation. Alright, so when we multiply everything out, we get the following 3x3 system. So first thing we want to do is take 2 equations and eliminate one of the variables. So I'm going to go ahead and choose the first and the second equation. I'm going to multiply all the terms in the second equation by -1 so that I can eliminate the f's. When I add up the 2 equations, I get -2d plus 6e minus 1